Welcome, this is Statistics for SPC, Operational Excellence. I'm Craig Otto. This is actually just starting to get into hypothesis testing, and this is going to be a very challenging subject, especially online, and it's very important that you keep up, and it all builds on itself. So I think it's important that you understand each lesson before you move on to the next. But I'm going to try to break it down so that it's easy to understand. I'm going to take it piece by piece so that we make sure that we do have a good understanding. So before I get to the slides, let me jump to just a quick example here. In industry, let's say we have two different processes, maybe two different machines, and what hypothesis testing is all about is comparing data. Okay, let's say you have one machine that is running a mean of 0 and a standard deviation of 1. Okay, now let's say a second machine is plugging and chugging along, it's running, but let's say the mean is 1. Okay, so in the background you see two different distributions here. There's a green one, which is my original first machine, but let's say this blue one is a second machine. Is it running differently? And what hypothesis testing does is, instead of guessing whether it is or practically looking at it, what it does is it looks at it statistically. It says, okay, I can tell you with a certain amount of confidence of whether or not these two distributions are different. So in this case, what it does is it looks at the mean of the blue distribution here, and if it falls outside of the critical region, and if you recall from the normal distribution when we found the area under the curve, so for example this right tail here in the red might represent the 5% of that distribution, 5% probability. So with 95% probability you can say that right now these two distributions are not different because the mean does not fall in that 5% range, or the critical region is what I call it. Now, what if the mean was 2? Well, now you're getting close, but it's still not statistically different because your mean hasn't moved into that critical region yet. So let's say the mean is then moved to 3 standard deviations out. Now the hypothesis test would come back and say, okay, hold on, there is something statistically significant here. This distribution seems to be different than the original because it falls within that the 5%. Let me move this distribution out of the way real quick. See how this tail here, that represents your 5%. So if you want a 95% confidence on something, 95% from this point to the left represents 95%. From this point to the right represents the other 5. Because remember, probability adds up to 1. So that's what we're doing when we're doing hypothesis testing, is just finding out, does it fall in this critical region or not? If it does, then yeah, there's probably some statistical significance. If it doesn't, it means then we really don't have enough data to prove that it's different. We never say that it's the same, we just say that we don't have enough evidence to prove that it's different. There's a key difference there. Okay, so let's get to the slides. This is some what I would call hypothesis testing 101. These are sort of assumptions, things to think about, things to consider. First of all, you have two different hypotheses. One is called a null hypothesis, and the other is an alternate hypothesis. Okay? Well, there's only, like in most cases, there's really only one null hypothesis, and usually it's a mean, some population mean is equal to whatever this other population mean is. So you have you're assuming that these distributions are equal to each other. Okay, so that H sub O, that is what, when you see that, that is the null hypothesis. Okay, now an alternative hypothesis, that's always stated second. So first you state the null hypothesis, and in this case it's that the means are equal. The alternative in this case could be many things. One is maybe one distribution is less than another. That's what they call a left-tailed test. So when you see that little less than, that's a left-tailed test. When you see it that, a second alternative might be that your distribution is greater than another distribution. That's called a right-tailed test. Okay? And then a third alternative might be that the distributions are not equal. You don't care whether it's less than or greater than. That's not important. You just want to know, are they equal or not equal? So, those are three outcomes for alternative hypothesis. And keep in mind, you only have one null hypothesis and one alternative. So you're doing one of these three tests, not all three at the same time. Okay? But when you design the test, you state that ahead of time. Okay? And you can never have, for example, you can never have an alternative hypothesis that the means are equal. That is not an option. Okay? And I'll have some tests and quiz questions regarding that. The null hypothesis can only be that they're equal. Okay? It can't say that they're not equal. It's always that they're equal. Okay? Now later we'll get in some different type of hypothesis testing, and that may change a bit. But in general, I'm just trying to tell you the general rules. Okay? Alright, now, as stated when I talked about confidence intervals and estimation in the previous session, there's always a risk in statistics. It's never black and white. You're always accepting that you have risk. And what I want to show is that there's different types of risk. And this first outcome is, let's say that H sub O is true. So in other words, that let's say the distributions are truly the same. So if we, and then up here, if we accept H sub O as true, meaning that we do know we're saying they're true, then you made the correct decision, right? And that probability is known as 1 minus alpha. Okay? So 1 minus alpha is that probability. Now, let's say we know that H sub O is true, so the distributions are equal, but let's say we reject H sub O, meaning we think it's false. That's called type 1 error. Okay? This is important. Type 1 error means with the corresponding probability, which is alpha, or the level of significance of the test, that's your type 1 error. So, and I think I have some questions on this too. Alpha is called the level of significance. Okay? And alpha, a lot of times, I remember, or I mentioned that you might have 95% confidence. That's what this is. 95% confidence here. 1 minus alpha. So if 95% confidence, your alpha is 0.05. So your level of significance is 0.05. That's just an example. Now your type 2 error is, let's get into this. Let's say H sub O is false. It's not, the distributions are not the same. If you accept it as it is true, let's say they're not the same, but you say that they are, that's known as type 2 error. Okay? And then let's say that H sub O is false, and then we also reject H sub O, meaning that we recognize that it's false. The statistics test says it's false. In that case, you made the right decision, and that probability, that 1 minus beta, that's called the power of the test. Okay? These are just things that you'll want to know. It's more of vocabulary type questions. We're not going to get into a lot of calculating the power of a test or the probability of beta. That's really not what we're going for here. You just got to be aware of it. Okay. Now, whenever you're making conclusions about data, it's important that you state things in the right manner because, like I said, statistics are estimations. There's risk involved. So let's say there's only two outcomes. Okay, you never say that distributions are the same. You just say that you fail to reject H sub O. So you failed to prove that they're different. Is basically what that's saying. There's not enough evidence. in the data to justify rejecting H sub O. Remember, H sub O says the distributions are the same. So this means that we retain H sub O with an understanding that we have not proved it to be true beyond all doubt. So even though the data may be close to being different, we still haven't proven it true. So we fail to reject the null hypothesis. Now, let's say we do the statistical test and it says, you know what, there is some evidence here that they're different. In that case, you say we reject H sub O. So we say there is enough evidence that in the data to justify the rejection of H sub O. That means that we choose the alternative hypothesis. That's one of these three, depending on what it is for each test. So one of those H sub 1s, or H alternative hypothesis, we choose that with the understanding that we have not proved it to be true beyond all doubt, but we think that there is evidence to suggest that it is, the alternative is possibly correct. Okay, so just some basic things to understand when we talk about hypothesis testing. Now what I want to do is sort of, okay, how does hypothesis testing work? Now I mentioned when we first started there's a critical region, and I mentioned that alpha when we started talking about the type 1, type 2 error. Well, alpha is just that probability in the critical region, or level of significance. Okay. The p-value, we'll talk about that. P-value represents the probability under the curve that second distribution meets, and I'll talk about that in a second. Your test statistic is basically the mean of that second distribution. So that if you can imagine that second distribution in here, the white line here is the center of it. Okay, so let's start in. So you have your null hypothesis, or your initial hypothesis. Maybe that it's stated that they're the same. Then you state your null hypothesis. The other thing you have to look at is a lot of times you just do this stuff, but you don't realize you have to make sure your assumptions are true. The first assumption is that your data follows a normal curve. If it doesn't follow a normal curve, then you can't use some of these tests. And the second thing is you're assuming that the distributions are equivalent. If they're not, there's tests out there that you can use, but if they're not equivalent in terms of variation, you really shouldn't be using some of these tests. So you got to consider those things. The next thing you do is select the appropriate test and the appropriate distribution. Normally we have the normal curve, and there's several tests. I'll show you those. We select the significance level. What I mean by that is, if we want 95% confidence, our alpha is going to be 0.05. It's 1 minus that. If we want 99% confidence, our alpha is going to be 0.01. If we want 90% confidence, our alpha is going to be 0.1. Okay, so you have to identify that ahead of time. All right, the next thing we have to do is compute the test statistic. So the test statistic is computed, and that's what's basically going to tell us, whether we're different or not. That statistic, if it's in the critical region, then you would say we reject the hypothesis. If it's not in the critical region, like it's showing here, then you would say it fails to reject. And that's another part of this is this p-value. And remember when we found the area under the curve, left bound, right bound, those types of things. This p-value is basically this test statistic number is kind of like your left bound, and your right bound is positive infinity. And that value, whatever that is, if that's less than 0.05, then we know that we can reject. And if it's not less than 0.05, then we know that we fail to reject. And I say 0.05 just because I'm used to using 95% confidence. But whatever your alpha number is, that's what you got to compare it to. So that's, you can see down here, you either reject or you fail to reject. And if the p-value is less than alpha, then you reject. And if it's greater than alpha, then you fail to reject. Okay. All right, and that's basically the first part of hypothesis testing. Again, try not to move on until you have this figured out, and take the time to go back through and just review it. And we'll step through this one by one. So we'll see you next time.